Okay, so continuing with chapter 7, section 1. And here we're looking at example 7-2 on page 374. Talking about the number of patients in a large urgent care center with 4 doctors found that they can see an average of 18 patients per hour. Assume the standard deviation is 3.2. A random sample of 42 hours was selected. Find the 99% confidence interval for the mean, or of the mean, either way. All right. So notice here, the fact that this urgent care center has 4 doctors is immaterial. The average number of patients per hour that they can see is 18. They told us to assume we know the population standard deviation is 3.2, and we are randomly selecting 42 of these hours. Okay, so in hour number 1, we're going to see how many patients did they serve per hour. Is it 18, and so on and so forth. Okay, we actually did that. We took 42 hours, counted up one by one the number of patients served in that hour, and averaged it together. And we found that the average for this sample was 18. So here we're going to find our 99% confidence interval for the mean. Okay, so whenever I'm doing a confidence interval, whenever I'm doing a hypothesis test, whenever I'm doing anything with, well, anything with anything in this class, basically, anytime I'm using any kind of probability distribution, I will make a sketch of that distribution curve, right? In this case, it's supposed to be the normal distribution curve, so it's supposed to be a perfect bell-shaped curve, but it doesn't always get, to be perfect looking. Anyhow, this will suffice. So what we want here is we want the internal area of this to be 0.99. Okay. Remember what we'll do is we'll do 1 minus alpha, and we'll set that equal to 0.99. So alpha, after some just quick ninja math, we'll see is 1%. Remember, whatever our confidence level is, right? Alpha is just the complement of that. So if we want to be 99% sure that our average value, the population average, is within this interval, then that means we only get to be wrong 1% of the time. Right, so what's alpha over 2? Alpha over 2 would be 0.005. Okay. Remember, our z table goes out to 0.0000. It goes out to 4 decimal places, so I'll write it like that. So we're looking for 0.50 in the book. Let me pause and we'll look it up together. Okay, so here I just kind of copied down what I found in my z table. Notice we have 0.0051 and 0.0049, so our value of exactly 0.0050 would be right in between these. Here, a z value of negative 2.57 will give us this area underneath the curve. If we plugged in negative 2.58, it would give us this area underneath the curve. So splitting the difference, we would average it to negative 2.575, but then we round it back up anyway. So we'll just, it will round up to negative 2.58. All right, so this is the negative one, negative 2.58. Over here we have the positive one, positive 2.58. Okay. All right, let's get the margin of error. The margin of error is z subscript alpha over 2. So we found our critical z values, these ones. times sigma divided by the square root of n. Okay, so we're going to be plugging in 2.58. Here we found it's minus, but we'll put the minus in and the plus in later. We'll deal with that later. Okay, sigma, what was that? Sigma was 3.2. And we're dividing by the square root of 42 in this case. All right, pause quickly. All right, so let's see. It's hard to read off of my calculator display. Oh yeah, there you go. 1.27, so we'll just call that 1.3. That's our margin of error. So the confidence interval is going to be for mu, and remember this is the sloppy way to write it. Chi bar plus or minus e, whenever, hang on a second, what happened here? Sorry. Technical difficulties, we'll be right back. Ah, there, I think that fixed it. Okay, so we'll do where did it go? We'll do 18 plus 1.3, so that gives us 19.3. Right, that's the upper bound for mu. And then on the lower end, we're going to take 18 minus 1.3. So that's going to be 16.7. Let's see, plus 0.3. Okay, yeah, that's it. So this is 99% of the time, 99% of the time going to contain the true population parameter, the true population average. Right. Only 1% of the time, so 0.5% is when it could be below this, and 0.5% of the time it could be above this. So that would be it.